Hello again, YouTubers. Dave out in Western Pennsylvania, USA. I work in the supercapacitor area, testing graphite components and various dielectric solvents, electrolytic solvents, and I'm focusing on the electrolyte lithium bromide to boost the rather poorly conductive abilities of the dielectric solvents I use. And the lithium bromide in 2 of the DESs so far readily dissolves at room temperature with just gentle stirring and light warming, and stays in solution at 20 degrees Celsius for a couple of weeks now. Here we're doing auto tests, and this is as described by ZKE Tech. That's the E-load device I use with great success. And I'm doing an auto test and step levels, which is for me an estimate of internal resistance in a series circuit. I'll come back to the input and data in a minute. I've done 2 of these studies. Here are the 2 supercaps, commercial, same manufacturer, each rated at 2.8 volts. Usually they're at 2.7, but 2.8 volts, 100 farads. Quick approximation, I found the farad was in the 90s as my own first approximation. So in other words, they're within specs. I have them in series. Now I don't bring them up to 2.8 volts times 2 or 5.6 volts. I just don't go up that high because I don't have any voltage balances. And one way to do that is with resistors in parallel. And since the same manufacturer and they're relatively new, bought at the same time from Amazon, I play it safe by keeping the potential down. So now I am charging them up at constant voltage. I'm going to 4.4 volts. And I wouldn't recommend going much above that. I certainly would not go to the 5.6 volts without, or you'll damage one or both of the supercaps. And I've noticed no heat concern so far in this very simple bench scale setup. I didn't solder anything because I'm not moving it around. And in series with the supercaps in series is a section of graphite felt. It's a composite. And what we have here, I'll record the dimensions and upload it. What I have is commercial graphite felt. It's been cleaned with ethyl alcohol and dried to constant mass. My undergraduate student does a lot of this work routinely. And sprayed on it aerosol graphite. In prior videos, I mentioned the manufacturer. So I put 3 coats on both sides. I wait 15 minutes or so between each coat and then leave it overnight to constant mass. So graphite felt, deposition of aerosol graphite that has an organic binder in it. I'm trying to boost the surface area, or at least see what happens. And then my undergrad does a nickel electroplate, what we call light, 4 volts for just a short number of minutes. And hopefully the nickel will serve as contact points, boost the conductivity, or at least that's what we're studying. And then we'll study the graphite composite before and after with scanning electron microscope. Now, what I did was, let's see if you can see the graph. Here are the parameter settings. Start current 0.1 amp, stop current 1.0 amp, cutoff voltage 0.30 volts, and the steps 0.1 amp, and we monitor the change every 10 seconds. Here's the data, and I'll also record it in the description. Maximum power output is occurring at step 5 and 6, and that is, for me, going to be an estimate of the internal resistance that graphite felt is introducing to the system, the circuit. Now, this is a dry graphite. No electrolyte solution has been applied yet. I'll package it up, and that will be done in the next number of experiments. What I will do next is remove the graphite from the circuit and see how the supercaps do on their own and compare it to the data I get with the graphite component in the circuit. I'll keep you posted on this aspect of my studies. I like looking at the components. The graphite felt, in my case, various treatments, oxidation, sonication, and then a study of how it performs with DESs, deep eutectic solvents containing lithium bromide, if they dissolve lithium bromide at 20 degrees Celsius. Thank you for watching the videos. We'll keep you posted, and I'll upload this data for you. Bye for now.